Everyone, welcome to this presentation. Today, I'm delighted to introduce the artist red rating industrial development platform and full stack development solution designed especially for industrial scenario. And let me walk you through what made rating a game changer for industrial development. Before we dive into the details, let me give you an overview of today's agenda. We will cover six major sections. First is an overview of the rating platform and its architectures. Second, the pain points in traditional industrial development that we aim to solve. Third, our core technical advantage. Fourth, the six integrate core functions. And five, our solutions of industrial development, and finally, our development support and ecosystem. And so let's begin with the part one, the rating platform overview. Rating platform architecture. The rating industrial platform is built up on five core pillars, as shown in this architecture diagram. It comprises the rating SDK, and it's our software development kit, and the rating HDK, the hardware deployment card, and our real-time operating system, artist-led professional editions, and the rating IDE and rating open platform. That's our ecosystem and service hub. Together, those five components form a complete vertical integrated solution that cover every aspect of industrial product development, from hardware design to software deployment. And then let me elaborate on what defines the rating platform through four key dimensions. As you can see, first rating platform definition. Rating is a hardware software integrated development solution designed specially for industrial scenario. And it's a full stack anonymous and controllable, which means every layer from the chip to the cloud is independently developed and managed. And our customer report it takes a 17% improvement in development efficiency, allowing them to focus on their core business innovation rather than wasting with the infrastructure. And second is minimalist development. We have achieved something unique here. Rating provide a MCU-like development experience on MPU class hardware. This means you get the simplicity and familiarity of the microcontroller development while fully unleashing the performance potential of microprocessors. No more wasting with complex Linux distribution just to bring an LED. Third, hardware software core design. Through the deep deep hardware software season, rating delivers open APIs and modular design, providing highly integrated and easily deployable solution. This core design approach accelerates the path to intelligent industrial equipment. Fourth, high integration core functions. Rating integrates six core functions, include data acquisitions, communication, control, industrial protocols, AI, and display, all optimized for industrial scenarios through modular design. This is truly one-stop service for industrial device intelligence. Now let's move to the part two, the pain point we address. The first pain point is painfully familiar to every embedded engineer. Development cycles that stretch across months or even years. There are three root cases. First is the chip installation, and adaptation is time-consuming. industrial device must support multi-chip architecture like ARM and RISC-V and increasingly many Chinese chips. In traditional development, each chip requires independent operating system plotting and driver adaptation, typically consuming 3 to 6 months per chip. And the second is the low-level driver development is complex. Industrial preferences are numerous and diverse. Driver development requires hand-coding and extensive debug. This debug. It takes 1 or 3 months to complete. This adds significantly to overall timeline. And the third is the protocol stack and middleware adaptation is tedious. Industrial protocol like SKF and Modbus combined with cloud protocols such as MQTT and OPC must each be adapted. Traditional solutions lack an undefined framework, resulting in a low code reuse and further extend development time. And the second critical pain point is system stability, or rather the lack of thereof in traditional solutions. So we see four major stability failures in the field. First is the film system are prone to damage. Traditional film system lose configuration parameters and production log during unexpected power failure, with data recovery success rate below 16%. This directly impacts system reliability. And the second is network protocols that are unstable. And third is the poor behavior compatibility. Different behaviors requires custom drivers lead to high crash rate, resource contentions, and deadlock. All causing system level failure that increase maintenance costs. And the last one is the control cycle and the data limitation. Traditional PLCs suffer from long control cycle and large task data, unable to meet precise machining requirements. This affects increment control accuracy and limited the product quality. And the third point is fundamental conflict between real-time control and intelligent upgrades. This thing can be included in 3 dimensions. First is the control and AI computing power conflict. AI inference consuming massive CPU resource, using real-time control takes latency to increase by 300%, making it impossible to meet industrial automation requirements. The second is the complexity of hybrid system integration. Engineers must simultaneously master both NPU and Linux development, and the two chairs are fragmental, user-friendly tools to scan and debug across the system is extremely difficult to create a high barrier to entrance. And the third is the real-time and AI computing across system design challenge. Coordinating the real-time control with AI computing across difficult system keeps debugging difficulty to increase. Traditional approaches simply cannot achieve efficiency sharing between those dimensions. So those 3 pain points, the low circles, the instabilities, and the real-time and AI gap, they are very problem that RuiQing was architected to solve. Now we arrive at part 3, the technical advantage that made RuiQing unique. Our flagship was called NPU experiment, but NPU performance, we have reimagined industrial development from the grow up to deliver five integrated to five areas. First is the graphical configuration. All the CPU parameters, pin functions, interrupts, clocks, DMA, and some parallel configurations are managed through the graphication tool. And components for storage, display, and other subsystems are equal streamlined. No more editing her fields by hand. And the second is the hardware time kernel for industrial precise. Our damage-resistant film system with full media manager ensure data integrity and extend the storage lifespan even under harsh industrial conditions with frequent power surging. And third is the SMP deployment solution. Our support our system supports enable resource isolation and double efficiency. It simply multi-core programming by allowing real-time stack to occupy dedicated core and dramatically boosting system performance. And the last is our rating IDE. Our IDE supports one-stop project creation, code generations, communications, and download. Hardware JTAG debugging includes step metrics, and during core SMB debugging, variable inspection, and resistor tracking, giving you complete system visible and control. And now let me zoom in. Let me zoom in our graphical communication given UI. All the I/O pin max pin relationships are configured through the VSO tools. No more poring over 1,000-page reference menus to find the right pin assignments. The system automatically performs the pin multi-pressing conflict detect, preventing configurations error before they reach the hardware. Similarly, all the peripherals are configured through the send interface, whether you are setting up UART, SPI, or iPhone-C, or or a specialized industrial interface. The process is visual, interface, and in real time. This is what we mean by MCU like on MPU class hardware. And the component level features follow the same logic. All the component functions, whether the storage subsystem, network stack, display driver, or industrial protocol mode, are configured through the graphical tools. You are simply select the components you need, configure their parameters through the dialog box, and the system generation the initialized code automatically. And this dramatically reduce the learning curve and eliminate the entire clutter of configuration errors. And the rating ID also tie everything together into the unfriend workflow. It provides one-stop system configure, development, computing, and download, all within a single environment. The IDE supports both straight-link and deep-link hardware debug, give you a fresh view in your debug post sessions. And the IDE full supports multi-core SMB debug. You can set breakpoint on your individual core, inspect pre-core resets, and analyze inter-core communications, all from a single debug session. This level of repeatability is essential when you are running a real-time control on a one core and communication task on others. One of Rating's most capability is hybrid deployment. running both Artist-Red and Linux on a single chip. The Linux side supports building root, Ubuntu, or OpenARIA embedded. Give a maximum flex of your application requirement. This hybrid architecture enables entire new paradigms for industrial device. For example, Artist-Red handle the real-time control tasks while Linux manages NPU accelerating AI interface such as Euro v5 object detections with seamless coordinations between tools. You are no longer need to two spare systems. Now one chip can do it all. And communication between the Artist-Red and Linux subsystem is built up on five components. All the layers on the top are PMSGs, our shared memory and intercore in the infrastructures. The visual UART emails serial protocol over RPMSG allow the two systems to communicate as if connected by a physical serial port, and the visual network interface environment network stack over RPMSGs create an Ethernet line interface between the systems. And the RPC unable to remote the posterior call across the boundary. Functions on one system can directly invoke functions on others, and the NFS allow the slaver call to mount the remote file system through the master core. Together, those five mixtures provide a rich, flexible communication framework that supports virtually any application architectures. And the industrial connectivity is where RuiQing truly shining. We provide a full stack industrial protocol side, include either card, Modbus, RTU, or TCP, and can open and OPC and OPC UA, all integrity and testing. Our either can master station achieve a cycle of less than or equal to 215 microseconds with radar under 5 microseconds, enabling microsecond level real-time control, and the multi-X and the multi-motion control. For applications require precise time coordination according device. We support IEEE 15582 precise clock. This means you can deploy a complete industrial control system without writing a single line of protocol code. And now the two components or either CAD stack will provide a conventional either CAD master configuration tool. This tool can help you to Unity manage slave station information, display and configure master parameters, and configure DC distribute clocks, show the station schedule and inspection information, and handles PDO data mapping configuration. This configuration tool eliminates the need to manually add CAD network discretion field, a process that traditionally requires specialize the expertise and is a highly error-prone. And last, let me summarize what those technical advantages mean in the practical. RuiQing integrates 6 core functions. First is data acquisitions, communications, and the control, industrial protocol, AI, and display into a single platform. We provide 5 reference solutions reference solution demonstration how those capabilities work together. Those solution is what we call industrial grade out of the box. By eliminating the integration effort that traditional consume the majority of project timeline, reaching reduce the over overall development cycle by 70%. Your team can focus on your application logic instead of wasting with drivers, protocols, and system integration. Okay, the part 4 is cover our core functions in details. And the first is about high-speed signal captures. Our high-speed data acquisition subsystem leverage ring buffers and multi-thread pipeline technology to achieve the bandwidth exceeding 50 Mbps. And we also use the DMA double buffering and zero copy technologies to deliver transfer latency below 10 microseconds with a task response under 5 microseconds with priority thread serving and hardware time triggering. The system supports industrial vibration analyzing and audio acquisition and power system monitoring. And about the low-speed data acquisition, we extensive sensor data acquisition about temperatures, humidity, and pressure, light sensor, and data I/O, and also about the multi-bus RTU device communicate via UART RS485 interface with sampling frequency from 0.1 Hz to 100 Hz, widely used for industrial PLC and power monitoring, ensure the real-time data acquisitions. And the annual input sensor sampling frequency is about 0.1 Hz to 10 Hz, used for battery voltage and environmental sense monitors. And the rating provide with sampling from 0.1 Hz to 100 Hz. Whether you need microseconds or microsecond sampling, rating has you covered. And about the real-time control, our current delivered microsecond response, our task reaching is logged at 1 milliseconds and the in-the-real latency is logged at 2.5 milliseconds. The multi-core coordination dedicated individual core to the SK controls and monitoring. And about the JADE, we provide a relatively low JADE that stay below 5 milliseconds, and those are graduated specifications for our customers rely on daily processing machines and robotic control. And about the HMI, reaching HMI offers fast board under 200 milliseconds, critical for real-time monitoring increments for resource constrained device. We provide little LVGR live waiting graphics. For demanding applications, our Qt-based HMI supports cross-platform capabilities and hardware accelerations, ideal for complex industrial control interface. About the network, reaching also supports electrical E15A every 2 processing clock with logged 30 nanosecond accuracy per hardware time sampling, and the Ethernet multi-NSC redundancy provide logged 50 millisecond favorable switchings, wireless redundancy via Wi-Fi and 4G and 5G seamless takes over while the network fails. And about the network communications, reaching provide 4 integration pathways. The IST4 API integrates the MQTT OPC protocols and the data synchronization. And about the artificial intelligence, reaching delivers 3 AI capability. The first is the high-byte deployment correlating computing. This computing runs real-time control on artist thread, while Linux handles the NPU accelerating the inference. Euro Free File deploys with one click. And the full-chain version processing achieved 100 FPS from camera input to detect classifications. And the multi-source data analyze refuse violations and temperature data with AI for predict maintenance and vehicle area warning. AI is integrated from day one, not an afterthought. And the preference is to showcase how RuiQing translates technological capability into a real-world solution. For CNC control, RuiQing provides a hardware real-time control, SMP multi-core processing, SDK masters, UI framework, hybrid deployment, and the full-stack autonomy, all on them stack platform. And the multi-access precision is significantly enhanced, and upgrade cycle drop 12 to 3 months. The HMS Wilson legacy ratings UI framework, industrial protocols, and faster board for rapid custom HNI development. And our key advantage is convenience secondary development, low cost for ownership, and fast time to market. And the EtherCAD control solution combine hub and hard real-time control, SDK master, hybrid deployment, and AI extensibility. And the multi-access control capabilities are substantially enhanced. Our platform upgrades the circle draw from 20 to 3 months. And in the industrial gateway solution, we provide industrial protocols, network protocols, and secondary development application for rapid low-cost gateway product, and the pre-integrate protocol stack like Modbus, MQTT, OPCUA, mean your gateway speak any language required right out of the box. And part 6 is about our deployment support and ecosystem about RuiQing. The RuiQing evaluate features the Rockchip RK3506, our first independently adapt platform with a triple-core Cortex A7 at up to 1.3 GHz. The RK3506 offers triple-core Cortex A7 at 1.3 GHz and with 128 MB and 1 GB DDR3, and dual 100 Mbps Internet and dual CAN 4, the CAN FD and 6 UART and Presto Bus or the SMC for the ADC or FPGA expansion. Full load SoC power stay below 650 microwatt with temperature rise under 17. FlashBro Matrix IO supports a brevity pin. And next is about the RuiQing open platform, provides the development center with API doc, quickly start guidance, and our Git report offers the hardware designs, example code, and reference solution. Everything you need is available online right now. And RuiQing integrity with the artist thread open source ecosystem bringing 3 benefits: access to the BattleTech open source package and drivers, a global deployer community for technology exchange, and ecosystem goes through as RuiQing expand into the broader industrial scenario. Okay, this today all about the RuiQing. Thanks for your listening.